Alright guys, so let's go ahead and do this timing diagram that we have over here. Okay, so here in this diagram, as you guys can see, we have an exclusive OR gate. Okay, so this has an exclusive OR gate looks like, which means like if either of the input like A or B, if either of them is equals to 1, so then the output is going to be 1. Okay, so only one of them has to be 1 for the output to be equal to 1. So that's what the exclusive OR gate means. Okay, so now like I explained in my previous video for the enabler, so if the enabler is equals to 1, so the output is going to depend on whatever the D input is. Okay, but if it's equals to 0, so it's going to hold the state in which it was previously. Okay, so this is how the truth table for the timing for the enabler for the D latch looks like, because every time the enabler is 1, so if the D input is 0, so the output would be 0. If it's equals to 1, so it's going to be equals to 1. Okay, and if it's 0, it's going to hold in whatever state it was previously in. Okay, so now with this, let's try to solve this. Okay, so here this is the input for A and this is the input for B. Okay, so if it's like below, so that means this is a 0. Okay, and if it's like above, so that means it's a 1. Okay, so now here you have to check for the enabler if whether it's 1 or 0 to determine the Q, right? And Q prime would simply be the complement of this one. So for example, if this is 1, so that this is 0, so that would be a 1. Okay, but in here we only need to know the Q. Okay, so this, like I explained before, this is 0, right? So let's go ahead line by line, the verticals dotted lines that you see. Okay, so this input is already given to us, right? So now let's move on to this one. Okay, so this is irrelevant. Let's go ahead and do this one. So this one is 0, and this one you see it's above, like it's not at the bottom, so this is 1. So you have 0 1 here, 0 1. So the output of this one, what do you get for the exclusive OR? Since it's an exclusive OR, so we get 1, right? So since we get a 1 for the enabler, so it's going to depend on whatever the D input is, and for the D is connected to A, so it means it's going to depend on whatever A is. So A is 0, so that means it's going to be 0. Okay, so previously it was 0, so it's going to follow this. Now here for this line, so let's go ahead and do for this line. So here we have a 1, right? And here we have a 0, so 1 and 0. So again, so the output would be 1, right? Because it's an exclusive OR. So then the enabler, we have 1 over here, so, and since we have 1, it's going to depend on whatever the D input is, and the D input is connected to A, right? So whatever the A input is, so A we have 1, so the output we're gonna have a 1. Okay, if it's above it's a 1, if it's down, so then it's 0. Okay, now for the next one. So I hope you guys are getting it. I'm going slow, so but if you guys have any questions, let me know in the comments. Try to explain. Okay, now again for this one, what is this one? This is like above the line, right? So this is 1, this is 0, so we have 1 0. Okay, so if it's 1 and 0, right, for the A we have 1, for the B we have 0, and what output do we get for the exclusive OR gate? We get the output as 1, right? But like if you're still not sure how I'm doing it, so let me make a truth table A, B and F, right? So if we have like, so I'm making a truth table for the exclusive OR, right? So here for the exclusive OR, you guys know, like as long as you have a 1, you're gonna get a 1, right? But if both of them is 1, then you get a 0, right? So yeah, so it's this, just that. So here we have the input as of A as 1 and input of B as 0. So 1 0, so what output do we get? We get 1, right? So that's why the enabler is equals to 1. And since the enabler, every time it's equals to 1, it's going to depend on whatever the D input is. And D input, you guys see, it's connected to A, so D becomes an A over here. Okay, so this input is equals to 1, so the output, it's going to become A1, right? So yeah, that's pretty much it. And if it's 1, it depends on D. It depends on D, the output, right? And the D is 1, so that's why the output is 1. Okay, now let's move on. Okay, so now here we see we have 1 again, and here we have 1 again, and 1 and 1, it's exclusive OR, right? So it means if we have both of them equals to 1, we get a 0. Okay, so now it is 0. Here the output of this one becomes 0, and we have the enabler set to 0. So if the enabler is equals to 0, what do we get? The output does not depend on D. It's going to hold in whatever state it was previously in. So previously it was high, so it's going to remain high. Okay, I hope you guys understood. When the enabler is equals to 0, it's going to hold in whatever state it was previously in. But if the enabler is equals to 1, it is going to depend on whatever D input is. Okay, now again we get a 0. Let's choose another colors. Okay, 0, and we get a 1. 0 1, again we get a 1 in for this one. Okay, so the output is 1 for the enabler. So if it's 1, it's going to again depend on D, which is A, so which is 0. So that means the output becomes 0 now. Okay, like it was high, we came down, we're making it 0. Okay, so that's why it's down now. So now again we're checking again, so now it becomes 0, and we have 0 and 0, so that's a 0 again, right? So the enabler is 0. When the enabler is 0, what we do? Hold the state it was previously in, so hold. So again 0 and 0, again we're holding the state, and this is what our timing diagram is going to look like. So that's it. If you guys didn't understand anything, let me know. I'll try to explain in the comments, and that's pretty much it. I think if you watch this video like a second time, then it might make more sense, but I tried to explain everything that I could. So yeah, that's it.